In today's lesson, we are going to discuss about density. Well, at the end of this lesson, you'll be able to define what density is. Also, we'll be able to answer questions from past papers involving calculations. Okay, so to start with, let's define what density is. Alright, so density is mass per unit volume of a substance. In other words, density is the measurement of the amount of matter which is mass in a given volume of an object. Okay, so one thing which is clear here is that density involves the mass which is there, also involves the volume of an object. Okay, so when calculating density, we use the formula below. Density is equal to mass over volume. Density is equal to mass over volume. Mind you, using the same formula, you can calculate volume. At some point, you'll be given density and mass. Then you calculate volume. Using the same formula again, you can calculate mass. You can either be given both density and volume. Then they tell you to find the mass. Just a matter of making the subject of the formula. So we use the same formula to calculate mass, calculate volume, calculate density. Okay, so now the units for mass is grams there. The mass is measured in grams, which is small letter g. Volume, it is cubic centimeters. Volume is measured in cubic centimeters. So when we add this, we make the units for density. And therefore, density is measured in grams per cubic centimeter. Grams per cubic centimeter, which is this one. Grams per cubic centimeters. Alright, so you can answer any questions can be possibly given to define what density is. You can just pick from the definitions there. And density is an important quantity because it enables scientists to identify and compare objects. So density is very, very important. Okay, so now we'll go direct to calculations on density. So our first example there, it reads, a metal block has a mass of 45 grams and a density of 9 grams per cubic centimeter. Calculate the volume of the metal block. So in this question, we've been given the mass as well as density. We are calculating the volume of the metal block. So when doing calculations, to make your work easy, always start by collecting data. By collecting data, I mean you collect what you've been given. So like our data here, mass we've been given, which is 45 grams. Density we've also been given, which is 9 grams per cubic centimeter. Volume we don't have, that's why there is a question mark. So in this question, we are calculating volume, which we don't have. So of course we use the same formula to say density is equals to mass over volume. Then we make volume the subject of the formula since we are calculating volume. So here we'll put over 1, then we do a cross multiplication there. Density times volume, that is density volume. Then mass times 1, that is the mass. Then we divide both sides by density, because volume has to be alone by making the subject of the formula. So we'll divide both by density. Here is density and this side density. Then we'll cancel density. It will remain volume is equals to mass over density. Volume is equal to mass over density. So once we reach this stage, we put in the parameters. Volume is equals to mass over density. So we get what we've been given from there. So our mass there, it is 45 grams, which is there. Then we get the density there, which is 9 grams per cubic centimeter. So when you punch in 45 grams divided by 9 grams per cubic centimeters, you get 5 centimeter cubic. That is our final volume, 5 centimeter cubic. Of course, you may be asked a question, or you may be wondering to say, but here we had grams, and on the final answer, you don't have grams here, because here the gram cancelled with this gram. You've seen? Then it was just the cubic centimeter. So that's why our answer there, it's 5 cubic centimeter as the volume. 5 cubic centimeter as the volume. Okay, so now we'll proceed to the next example, which is example 2 there. And the question reads, a piece of metal has a mass of 240 grams. When it was placed into a measuring cylinder containing water, the water levels rose as shown in the diagram. Full stop. So now calculate the density of the metal. So we are calculating the metal. So you need to vividly understand this question, because understanding is very important. Alright, so now we proceed. We always collect data. That's our data there. Always collect data. So mass we've been given as 240 grams. Volume, as you can see the diagram there, we've got two volumes. There is volume 1 here, which shows the water level at 50 centimeter. Then we have volume 2 there, shows the water level at 80 centimeter. So the question there, it was saying a piece of metal has a mass of 240 grams when it was placed into a measuring cylinder containing water. The water level rose as shown in the diagram. So now, initially, the water level was at 50 centimeter. Then the metal was now placed into the measuring cylinder. Then the water level rose to 80 centimeter. So here we've got two volumes. There is here volume 1 and there is volume 2. So such questions, how to find the actual volume, or you've been given the first and the second volume, you subtract volume 2 minus volume 1, then you get the final volume. I repeat again, for you to find the initial volume here, you need to subtract this volume 2 minus volume 2, then you get the final volume. Okay, so that's our formula there to say volume 2 minus volume 1. 80 centimeter, which is there, 80 centimeter minus 50 centimeter, which is equals to 30 cubic centimeter. So that's our volume there. That's our volume, 30 cubic centimeter. That's our volume. So now we go direct to the formula. The formula says density is equals to mass over volume. Okay, then we just put in the parameters there. Mass we've been given, which is 240 grams. Then volume, it's this one, which is 30 cubic centimeter. So there are 240 grams divided by 30 cubic centimeter. So density is equal to 8 grams per cubic centimeter. That's our density there. 8 grams per cubic centimeter. So if you have any questions or queries, you can comment. There's a comment box section there. You can comment and ask any questions. Alright, so having discussed these two examples, we can now look at an examination question. So this is paper 1, question 15, 2014. This is paper 1, question 15, 2014, grade 9. This is grade 9, paper 1, question 15, 2014. It was a multiple choice question. Okay, so now the question is there. It reads, the diagram below shows an object with dimensions 5 cm times 4 cm times 2 cm. So this is our object there. It has got 3 sides. As you can see, there is 2 cm there. We've got 4 cm there, and we've got 5 cm there. Alright, so let's now read the question. Question, if it has a mass of 100, so this dimension, it has a mass of 100 grams. What is the density of the material? What is the density of the material? So we want to find out the density of the material. Right, so as usual, we plug in the parameters. First of all, we find the data there to say mass. We've been given there, as you can see, it's 100 grams. So our mass there is 100 grams. Then volume. The question reads, the diagram below shows an object with dimensions 5 cm times 4 cm times 2 cm. So when finding the volume for this one, we get the formula to say volume is equal to L times B times H. So now 2 cm times 4 cm times 5 cm, our final answer is 40 cubic centimeter. So that's our volume. So our mass there is 100 grams and our volume there is 40 cubic centimeter. Alright, so now we go direct to the formula. Formula is there to say density is equal to mass over volume. Density is equal to mass over volume. Okay, so density is equal to mass over volume. Then now we just plug in the parameters. Mass we've been given as 100 grams there, and volume we have calculated there as 40 cubic centimeter. So our mass there is 100 grams. Then our volume there, it is 40 cubic centimeter. So now density is equal to 2.5 grams per cubic centimeter. 2.5 grams per cubic centimeter. That's our final answer. That's B. Okay.